Hi, everybody. The first thing I want you to do is to please get out your packets, your notebooks, and we are here now at cycle four. In cycle four, instead of calling intramolecular bonding, we looked at ionic and covalent. It's intermolecular bonding. So we're going to be talking a lot about what that means. But given this online setting and given the importance of the things coming next, we are going to really drastically edit the information in this topic. So the first thing I want you to do is just go through and cross out all these warm-ups, okay? Not going to be using those pages. Come on, buddy. Okay, cross those out. All right. And I'm just having you cross this out just because it makes me feel better. So that out. So sad. This makes me so sad. All right, cross that out. Cross that out. Okay, we are going to keep this. Okay. Gonna cross this out. Cross this out. And we're going to keep this. And we're going to cross this out. Oh, God, I love these labs. I'm crying. Okay. And we're going to keep this. Now, this does not mean that we're not going to try and do some activities. Actually, this is going to be a pretty demo-rich section. Hopefully, we'll be able to pull that off. But I just wanted to ground you in that. So what I want you to do now that you've crossed all that out is I want you to find a blank piece of paper in your notebook. You could actually use part of this warm-up. You could use anywhere in here. But for this unit, when we're taking notes, I'm going to ask you to find some blank paper here. Please just staple it to your notes or do something in a really organized fashion because I don't want this stuff flying around everywhere. So what you're going to be doing today is you're going to be working through a simulation. And the simulation here is going to have two modes. There's going to be the 2-atom mode and the 3-atom mode. This real molecule mode, ignore that. It doesn't work. So 2 atoms and 3 atoms, notice we're talking about covalent bonds or sharing of electrons. And when you're doing this, there's some things that I want you to pay attention to here. You're only going to be clicking on this link that says bond dipole or partial charges. Okay, and you're going to be playing around here with this electronegativity value here, and you're going to be noticing this arrow changing here, and you're going to be noticing some charges appear. And same thing for the 3-atom mode, and that's down here at the bottom, by the way. You can toggle back and forth that way. You have now 3 atoms, and you have the electronegativity values to play with, and you have the bond dipoles and the molecular dipole here to play with. And you can move these bonds around to make it linear or make it bent. Those are the only two options here. So what I'm going to do now is I want to really define for you what are these terms before you go into that. And that's where I want you to start taking some notes down right now. I have a blank sheet of paper. Okay, so let's just start off by looking at a molecule, A covalently connected to B. And remember, in a covalent bond, it's made of 2 electrons. Okay, so first off, this is a covalent bond. And we know that because the electrons are being shared. Okay, and if we had a situation like this, let's look at A and B over here. And I'm not doing the whole octet, I'm just showing 2 electrons here. If B fully owns those electrons, it's got a -1 charge, and this has a +1 charge. And this here is our ionic, and remember that's not a bond, they're stuck together because A's like, what? Give me my electrons back, fool. All right. So there's some terms that we are going to be dealing with here. Okay. And the first term that you're going to be seeing is electronegativity. Super important term in chemistry. Okay. Super important term. So what is electronegativity? And electronegativity, by the way, is this thing that you're going to be playing with down here. So each atom has their own electronegativity. So electronegativity is defined in Ramsey terms is the pull an atom has on a pair, these right here, of shared electrons. Now, because it's the pull on shared electrons, we know that that must be the pull on electrons in a covalent bond. Okay, so this is redundant, but I'm going to write it because I'm just keeping it real. So what are the implications of that? Okay, so let's say that B pull, and let's actually go down here and let's do it this way. Okay, so let's say we have A and we have B. So let's say that A has a lower electronegativity than B. That means B pulls harder. So we have the bond here, and if B pulls harder, that means those shared electrons are going to be closer to B. And we actually draw an arrow pointing to B. Put a little line here. And this means that if this is A's side over here, and this is B's side over here, that means most of the electrons are on the B side. And this is called a dipole. Okay, so if we had a situation down here, let's look where we had A, let's do it over here. We had A and B, and let's say A had a higher electronegativity. Okay, that means the arrow would be pointing in this direction towards A, and that is a dipole. Now let's say we had a situation where you had A and B, and they both have equal electronegativities. That means that the electrons are right there. There would be no arrow. The electrons are equally distributed on both sides, and that would be a situation where there is no dipole. Okay, so that defines what electronegativity is and what those dipole arrows are going to do. They're basically pointing in the direction of the element that pulls harder on their electrons. Okay, but let's go up and look at that other thing I'm going to have you toggle on, and that thing is called partial charges. Okay, and you notice when I do that, we see these weird like squiggly charge type things. So first of all, let's look up here. Why is B negative? Well, B is negative because the electrons were fully transferred from A to B. So now B has more electrons than it did before. It owns those electrons. A does not. Well, in a covalent bond, we never have a full transfer. These are shared electrons. But in a situation where B pulls harder on the electrons than A, B does not have a -1 charge, and A does not have a +1 charge. But B kind of has a more negative charge than A because the electrons are closer to B. Let me say that again. B does not own the electrons like it does in this situation where A is a giver and B is a taker. Okay? Here, B is like, I am -1. I have the electrons. That's what these brackets are showing. In this case, B does not own them. Look at this covalent bond. A still has some, but they're closer to B. So B is not -1. B is kind of -1, or we're going to say kind of negative. And the way we show kind of negative is not showing a full charge like this, but showing a partial charge. And that's the symbol, that's a lowercase delta. And that would make this partially positive. Okay? In this case, there is no partial charges because the electrons are equally distributed. There is no dipole. But when there is a dipole, meaning somebody's pulling harder than the other, wherever the arrow is pointing, it's pointing in the direction of the negative end of the dipole. Conversely here, A is pulling harder on the electrons. And because electrons are negative, A is not negative, it's partially negative. And B is partially positive. So these partial charges are ways of showing how the electrons are distributed in a covalent bond. Okay? So electronegativity is the pull an atom has on a pair of electrons, a pair of shared electrons, in a covalent bond. B pulls harder, but they're still shared, so it's not negative, it's partially negative, making A partially positive. A pulls harder, making it more negative than B. It's not fully negative because B still has some. It's partially negative. So you are going to be playing around with those values here, and you're going to be playing around with these values here. Now, I'm going to let you know that things are going to change here when you move these around in this one. Okay, so I'm going to be scaffolding you through that. Thank you.